looking at the cube root of 64, this 64 to the 1/3 is 4. And now I am squaring that and b to the 2/3. So writing it down this way for some of you would probably be very helpful. That's how we get 16b to the 2/3. Okay. I want to go to your notes right now and just keep your homework. If you're understanding that, I'm going to have you hand that in a few minutes. Here's the other thing. What do we do when we take exponent, base times same base? What are we doing? We are adding our exponents, right? So when we have x to the 4th times x to the 7th, we should be adding and getting x to the 11th. When we have m to the 3rd, yes, definitely move over. We have m to the 3rd and m to the 5th. Raised to the 5th power, we are doing what when we multiply with our, taking a power to a power. If we have exponents, we are doing what with those? Multiply. If we have division, the opposite of multiplying with the same base, we should be subtracting. And then we have this, h to the 3rd plus h to the 2nd. We can't simplify. That's our nothing, right? So when you remember when we did our exponents, I said nothing. Nothing is when you take h to the 3rd plus h to the 2nd. But I like this one even better. If I have h to the 2nd plus h to the 2nd, I have 1h to the 2nd and 1h to the 2nd. That is 2h to the 2nd. Do I do anything with the exponents? Nothing with the exponents. So this is looking at what we do with the exponents, right? When you are adding and you add this same thing together, you do nothing to the exponents, right? They stayed as h to the 2nd. When you multiply with the same base, x to the 4th times x to the 7th, what did we do to our exponents? We added those exponents to get x to the 11. When you have an exponent raised to an exponent, so exponent to an exponent, what did we do? We multiplied those. That's where we have this m to the 3rd raised to the 5th. We multiplied those. Please put your head up. Thank you. So as you are taking a look at those. So that review is going to kind of lead us into what we are doing today. So we are asked to simplify our expressions. So if we are simplifying these, and by the way, I'm going to hand back to you also your notes for the last unit. So some of you, as you are looking at those. So if we are looking at this one, we want to simplify. We're going to multiply x to the 1/3 times x to the 2/3 gives us x to the 3/3. We don't have to write 3/3, right? We are just going to write x. Do we have to put x to the 1st? No. Could you put x to the 1st? I accept x to the 1st. We just pretty much want to write x. So we're looking at this next one. We're multiplying again. We're going to add our, we have the same base, so we love that with our fractions. We're going to look at a to the 4/5. So it says simplify it and write it in radical form. Now this one was nice in radical form because it was simplified, right? So you go and you start this with a to the 4/5. And then it says radical form. Underline, highlight, go back, make sure. This is kind of where people will make mistakes on the test. They'll give it in exponent form and not radical. So we're taking a look at that next one, a to the 1/3, ab to the 1/3, and b to the 1/3. Again, if I'm looking at that, I'm going to have a to the 1/3. I have b to the 1/3. I'm kind of getting rid of this parenthesis, right? And then I have times another b to the 1/3. The most common mistake is I'll have people tell me this answer is a and b to the 2/3. So right now we know we have a to the 1/3 and b to the 2/3. We want to write it in radical form, which simply means we want the cube root, right? Cube root of a and b to the 2nd. 8 And this is where some of you are like, oh, should I put the 1 in there? You could, but cube root. Okay, so the denominator is 3. That's what you're looking at, right? When you look at that denominator, that's what goes out here. Okay, that's what goes outside. The A is to the first and the B is to the second. Okay, so let's start simplifying here. First thing I'm going to write down is 16 to what power? 1/2. And I'm going to have x to the 1/2. And I'm also going to have x to the 1/3. And I heard some of you say, oh, 16 to the half, that's 4. Yes, awesome. We got that. That's 4. I have x to the half and x to the third. I have to have a common denominator. It's going to be what? 6. So if I'm getting that common denominator of 6, right, this is going to be 3/6. This is going to be 2/6. Which means when I add that, I'm going to have x to the 5/6. This is an exponential form. We don't want the answer in exponential form. We are going to keep, does the 4 have to be underneath the root? No, it's just 4. It's 4 to the first. What has to go underneath is our x to what power? The 5th, and the index is 6. Okay, is that making sense? Break it down, show your work. Write those things down each time as you are looking at them. Okay, so as we look at that next page, again, we're doing a little more simplifying on this page. They get a little ugly. So we are starting off with, this is our coefficient 2 with the cube root of a plus the coefficient 3. I want you to think back as if you were adding 2x plus 3x. 2x plus 3x is 5x, right? You add the 2 and the 3, adding like terms. You've done this. This is way back at the beginning of the year. Adding like terms, okay? So we get 2x plus 3x gives us 5x. This is going to be the same thing. We're going to add the 2 and 3. Because these are exactly the same, it is the cube root of a, the cube root of a, we are going to have 5 times the cube root of a. Okay? I have 3. I have the 4th root of b minus, what number's in front of this if there's no number? 1. Write it in. So we are simply thinking, kind of reverse distributive property if you wanted to think of it that way. These both have this key factor. Are these key factors the same? Are they the same? No. If they're not the same, to simplify when possible, this one can't be simplified, right? But if we're looking at it, we're going to write those as exponential form. So we're going to go back to this one, and we're going to go exponential form. And the reason I did this one on the first one is I'll often ask students on the test, on the quiz, whichever form you start in, they want to finish that way. So really watch, and if you need to highlight the reading, like some of you on the last test really missed the decrease by 12%. You added 12% on the test instead of decreasing. So this one, if we are looking at that answer, we are looking at 5 and a to what power? 1/3. Not to the third, but 1/3. Big difference, okay? Yep. So, like terms, we're adding the coefficient. This is the answer we are looking for this problem, right? Not here. This is our answer. All right, so we're looking at this next one. And you think, oh my gosh, there is no way. So, you're finding the square root of 16. What is the square root of 16? 4. What is the square root of x to the 4th? X to the 2nd. Plus, what is the cube root of 27? 3. And we have the x to the 5th raised to the 3rd. So here's what I might be thinking of that one when we are simplifying it. As we look at that one, we are going to have x, and we might have thought of taking it to our, like the roots, but we're asked to write it in what form for our answer? exponential, which means the denominator is 5, numerator is, or denominator is not 5. Denominator is what? 3, thank you. And the numerator is 5, right? The 3 was to what power? It's like a 1, right? So can we add these together? That is our answer right there. We cannot add those together. 4x to the second plus 3x to the 5/3. Okay? The exponents aren't exactly the same. These are not like terms. Now, if it would have came out to be something like, I would have got 4x squared, and it would have been plus 3x squared. So like say this was 27x to the 6th. If this would have been, if you would have had the cube root of 27x to the 6th, that would be this. Agreed? And then I could add those together and get an answer of 7x squared. But I can only add the coefficients if the variable part is exactly the same like terms. Okay, does that make sense? Okay. So this is our answer, keeping it like this, just as we simplified, no other steps. Okay. The next page is you're looking at that next part in your notes, so we're trying to simplify using all of our exponent properties. What form do they ask us to leave our answer in? Radical for the first ones, exponential for the second one. So you are making sure that when we do these first ones, we are doing radical form. In the second ones, we are doing exponential form. Okay? You can do it in this form with exponents, but then your final answer has to be a radical. So if we are multiplying, we want to add, right? So if we are looking at this, we're taking a to the 2/3 plus a to the 1/4. So we're going to maybe rewrite this as a to the denominator should be 12. So we are going to have 8/12, do you agree? Times a to the 3/12. 8 plus 3 gives us a to the 11/12. I have it in exponential form. I want to make it radical. What is going to be my root? What's going to be the index? 12. And a to the 11. Yes? Okay, we got 5. There's a 1 in front of this x squared. That's just 5, right? I have x to the 1/5 and x to the 2nd. We're adding those together. Someone said, if you remember on the one test where I marked it wrong, if you had 2 and 1/5, because we don't write that as a mixed number. But 2 and 1/5 is going to be how many fifths? So 5 times x to the 11/5. So if we are looking at that, we are going to be looking at 5. The index is going to be 5. 5 and x to the 11. Can this be simplified? Can you simplify inside here? Okay, so if this is 5, we want to think of dividing by 5. So if I break it down and I go something like 5 times the 5th root of x to the 10th, do you agree, times x. Doesn't that give us x to the 11th? Okay. Can we find the 5th, can we take x to the 10th and divide it by 5 evenly? Yeah. So I picked 10 because I know it's divisible by my index, right? I wouldn't want to pick 2. I wouldn't want to have 3 if I'm breaking that down. So the simplest form of this answer, 5x to the 2nd times the 5th root of x. On the test, I'm looking that you go this step further. Yeah. Okay? This answer is okay. This is correct. This is the most simplified answer. So if we're putting simplified, okay, 5x to the 2nd, and the root out here is the 5, right? And then that's just x to the 1st. All right, so let's look at those last two as we are looking at those last two problems. they're asking us to do it in exponential form. Does the 4 have to be to any exponent? Nope. Ooh, this is kind of ugly though. We got the cube root of 3x to the 6th. So here's what I want you to be thinking of. That this is the 4. It's times 3. What is my fraction going to be? The numerator is 6, denominator 3. X, same thing, right? Numerator 6, denominator 3. Don't multiply the 4 and 3 together, right? Because this is 4 times 3 to what power? 6 divided by 3 is 2. So this is 4 times 9, which is 36. X to the 3 over 2 is x to the 2nd. Okay? Minus. The 2 is going to be to what fraction? Denominator is 2, numerator is 4. X, numerator 4, denominator 2. Why denominator 2? Because this is an index of 2 right here. So I have minus 2 to the 2nd, right? X to the 2nd. 36 minus 4x to the 2nd. All of that work to get the answer of 32x to the 2nd? Yes. That's what your paper should look like too. Yeah. 32x to the 2nd. They don't cancel. You can't just get rid of the x to the 2nd. So you have 36x to the 2nd minus 4x to the 2nd. So this one is like, I agree, 32, and then, so this next one. So sometimes you're going to be able to simplify and sometimes not. If we take a look at this next problem, as we are looking at this, we are going to have 27 to what power? 2/3. X to the 2/3. Cube root of 27 is 3, and when you square it. So this is really telling us, right, 27 to the 1/3 and squaring it. Now some of you don't need to write that down. Some of you are going to put this right in your calculator and go from here to here and tell me that that is going to be 9. The x is going to stay 2/3, correct? Plus, I'm going to definitely use my calculator. I was also amazed on the test I had people that not use their calculator. You have it in front of you. 256 to the 1/4? 4. Put it in your calculator if you're not sure. It's 4. Now we are putting in x, and it is to the 2/4. X to the 1/2. Simplified. This one is not being squared, right? There was not a parenthesis with the 2. This is just 256 to the first power, so that's why 1/4. Here, this is like 27 to the 2nd and x to the 2nd, right? You have to distribute that, okay? So you have to be really careful. This is your answer, right? They don't look alike. This is your answer for that problem written in exponential form, okay? So, you are looking at this assignment, G4, and with this G4, I am also going to